Hello everyone, once again welcome to a new lecture, that is essential requirement of indicating instrument. In previous lecture we were talking about ballistic and de-accelerometer. We were talking about how the construction and the working of galvanometers are been done, how the practically Laurent force will work to moving the both type of galvanometric devices. One important point, the torque providing the force of deflection for moving the pointer in such type of indicating instrument can be undefined, and it is defined in our continuing session, where we're talking about how a indicating instrument providing the torque and type of torques provided differentiate the PMC meters, MI meters, and particularly EMC instrument. And in value of this particular talks, we have different type of talks values also, like one of the talk that is talking about moving backward of a indicating instrument to its zero position, or damping torque, we say it will slow down the oscillation of particularly indicating instrument. Now in enhancing of this lecture, we will continue this particular part. We will talking about it in this unit, talking about the essential requirement of indicating, so like deflection torque, controlling torque, damping torques, and in continuing for the lecture talking about moving an instrument, PMC instrument, and EMC instrument. Let's start with indicating instrument that are will indicate a particular value in our particularly calibrating scale. Using example are voltmeters, ammeters, and wattmeter. The essential three type of essential requirements are three type of talks which will propose the three type of system. First system to be a deflection system. It is a system which will require or it is a type of mechanism or instrument which will physically affect the electrical current or voltage to produce a mechanical force. This particular deflection force can be caused to pointer to move to a particular position in the system. The magnitude of this particular deflection force is basically depending upon the electrical quantity to be measured in the system. And this deflection system are to be in the various parts, like electrical type, electrostatic part type, yeah, magnetic type, or electromagnetic type. As a part of belonging, we will continue this type of discussion in next part also, but this deflection torque is not a necessarily one to be discussed in elaboration. So we'll continue our lecture by the second type of system, that is called controlling force or controlling system. It is a particular force which will required to bring back the pointer to the zero position. Okay, basically when we force a particular pointer to a given indicating position or a true value in our indication measurement, we will require that the pointer must be bring back to zero position for next measurement. The force required to bring back the pointer to zero position is known as particularly your contouring force. Now I have to explain it. We will also explain it particular type like this. If you have a measurement device pointing starting from zero, if you wanted some measurement around 5 ampere, okay, the instrument is well mannered and give a deflection of 5 ampere, give deflection of 5 ampere. But after all the indication for 1 to 2 minutes, and you noted down all the values, now you wanted the particular pointer to move back to your original position, that is zero position. Okay, so the particular force that move bring back, that is called controlling force, TC. We will denoted by TC, and it will be noted down that this TC force is it will be opposing force of deflection force. Okay, that is the opposition of deflection force. Okay, now talking about one more points in this particular part, where the pointer as a reset in the particularly opposition force. The two type of controlling force are being required. First is spring control and second is gravity control. Now talking about one by one control, that is spring control. This is the most commonly used control, used in PMC meter also, and it is used in MI meter also, moving an instrument. It is a basic function, it is work on the basic function of your spring, that a spring which will be fixed on one of the part, and when a spring is forced to expand in one particular direction by the force, it will expanded. Okay, it expand in one of the direction. When the force is regarded to zero, when a force is zero in the spring tension force, then the as a spring have a natural instant that if it expanded and the force is zero that expanded, it will bring back to its natural position, or it will decrease down to its natural position. Okay, so this particular expansion and reduction to its size is a main particular intensity or main particular principle behind the working of spring control. Okay, now, in the particular part, there are two type of one or two hairspring. In case of moving iron instrument, it is only one hairspring. In type of PMC instrument, there are two hairspring. This hairspring are made of phosphorus bronze material. This particular phosphorus bronze material are fixed at to the pointer, one at the pointer and other is attached to the spindle of the system. Okay, when the pointer is a zero position or a scale of zero, spring at the spring is a normal position. It does not mean an expansion process or a reduction process. Now, when a pointer move as we can particulate it also like this, it is a pointer there. Okay, we will provided some spring like this and we fix to our spindle. Whenever pointer move due to some deflection torque TD, due to some different type of functional principles, the pointer moved to some position and the spring also expanded in that particular direction. Whenever the spring produces due to the deflection torque, an opposition force or contouring force will be provided in opposition to this, that is called TC force. This force always wanted, it is equal opposition to deflection force. Okay, in each and every instant TD is equal to TC. At steady state, TD equal to TC. Whenever TD is equal to 0, whenever the deflection torque is 0, the spring is moved back to its original position. Okay, the balance with moving system depending upon the gravity considered rotation can be reduced the friction between pivot and bearing also. One of the systematic diagram of this particular spring control you can see where the a pointer will be there. This pointer will be attached to some of the spring control and will be attached to one of the your pivot control. Whenever the deflection torque is there to move the position, the hairspring will be expanded. Whenever the deflection force is zero, the spring reduces position to its normal position, so it will bring to zero. Okay, this particular spring control having the fundamental features that it controlling torque is directly proportional to theta or angle with which controlling torque will be deflect. Like as I say, the pointer from it is a 0 degree Celsius, 0 degree, it is moved to some of the pointers say 50. The angle between them is assumed to be 30 degree. Then the controlling torque whatsoever produced is directly proportional to that angle of 30 degree. If more of the particularly angle theta angle or a area covered by this particular pointer will be increases, controlling force will be more in that instant. Okay, now as we know, in normally in case of PMC meter, deflection torque is directly proportional to current provided in particularly your moving coil. Then at the final position, as I say, at the steady state, deflection torque is equal to controlling torque. Then we will say theta is equal to I, whatever the particular pointer cover the area directly proportional to current. Providing this type of spring control always be produce a uniform scale in your instrument. It is one of the major advantage of a spring control where the your scale is uniformly scaled. There is a the area when you provided some scale, there should be distribution is equal. Whereas some of the disadvantage of this type of spring control that, as I say you in previously also, that spring have its inherent property that if the in case of fluctuation of temperature, this stiffness is also fluctuated. In case also one of the thing that if the spring is used for a long period of time, it will lose its elasticity. So zero position cannot be achieved in a longer period and can be provided some calibration to reduce its error also. Okay, some of the disadvantage of spring control are there. Double spring control, as I say, used in the PMC type of instrument. So above and below, as I say, ki, upper and lower hairspring, the current is moving from upper part, moving to some of the moving coil and going toward the lower coil to the side. This type of control is used only in PMC meter of instrument, permanent magnet moving coil instruments are with there. Okay, second control, that is called gravity control. It is one of the basic example. As we know, the gravity is very function. It will pull each and every instrument toward the gravity, toward the earth. So in this instrument, we will assume that a pointer having the two weights. First is a balance weight, and second is control weight putting toward it. Okay, now what is a function of this particular force? It will be moved like that. There is a pointer. When the pointer moving to some of the state, okay, the balance weight and pivot weight provided some of the fluctuation in that condition. What are these fluctuation condition? You will see in one of the right hand side case, when the pointer when I move from A position to B position, it's particularly balance weight, in that particular direction, and is controlling weight in this particular direction. As the controlling weight of the position, it will provide two type of gravitation pulls, as W is in the G manner and is a vertical direction. One of the particularly alignment to be W sin theta and one of the alignment to be W cos theta. W cos theta purpose that it will oppose the balance weight condition, and W sin theta oppose the, it is a type of a controlling force which will move backward the pointer to the original state. It is a W sin theta that will causes overall opposition or controlling force to the system. Okay, it is one of the fundamental feature. As we say, when a pointer is moving towards some direction, W sin theta opposes the function. It exerts a force to it is a basically a controlling torque. So controlling torque TC is equal to W sin theta, and L is the length of a particular pointer from the controlling bit. So WL sin theta. As we know, deflection torque in case of PMC instrument, it is directly proportional to current at the steady state. TC equal to TD. Then we will say your current is directly proportional to sin theta. Or we say in case of gravitation control, the scale is non-linear, or we say it is not, does not be uniform at all. Okay, so scale is non-uniform, one of the disadvantage, but one of the more disadvantages in case of your spring control, you can set the particular instrument in vertical as well as horizontal position, but you must position the particularly gravitational type of control instrument in a vertical position such that gravity will be pull it down. Okay, it is one of the advantages. As a spring processes, you does not be calibrate each and every time every time by the ear, or you can it's a particularly controlling mechanism does not be changed by temperature. It is free from fatigue, and most importantly, it is less expensive than your spring control. Okay, that's all from this particular lecture. We will continue second lecture by the damping torque control. We will talking about how we'll reduce the oscillation in the indicating instrument. Thank you so much.